Let's have a look at this question then. It's the integral between 0 and 0.4 of this integral. dx, we need to use a trapezium rule, 5 ordinates to 3dp. I've written down the booklet formula here so that we can just input the values. So the first thing to get is h, b minus a. So here you can see the interval. So the b value is 0.4, the a value is 0. So it's 0.4 is b, minus a, which is 0, over the n. Well, we've got 5 ordinates. We start from y0. We're going to go up to y4, aren't we, on the formula? So n is 4. So we got that. So we can see that h is 0.1 then. Good. So here we need x. We got y0 up to y4, haven't we? Because n was 4. Because there's 5 ordinates. So we need x0, x1, x2, x3, and x4, isn't it? So we divide the interval into these points. So we're going to need to divide it into 4. So the first one will be 0. Next one will be 0.1, 0.2, 0.3, and 0.4. That will give us 5 ordinates, 4 intervals. Divide 0.4 into the 4. That's the difference there. And you get a difference of 0.1. So the increment is 0.1 each way. So if x0 is that, put 0 into our formula here for the integral value. The integrand here, 1 plus 0 cubed to the power 3 over 2. That's 0, so it's 1 to the power, which is just 1. Then y1. So we need to just repeat this same process. Let's write down what we've got here for 0.1 cubed. 3 over 2 we can write as 1.5. And then y2. Just repeat the same thing. And y3. And then lastly, y4. Now we need to tap all these out. We're going to want our final answer to 3dp, so it's good if we can work to about 5dp, isn't it, with these, so that we've got a margin of error sufficiently wide. So let's have a look at our calculator then and tap these in the calculator. So this one here, so we'll do that then. So it's brackets 1 plus 0.1 cubed, 1 plus 0.1 power 3, ground level, close bracket, power, and it was power 3 over 2, which is 1.5. That's what we've got then. So we get 1.00150. 1.00150. Next one. Now all we need now do is toggle back and change that 1 to a 2. Press equals. 1.01202. And we can check that when we flick the calculator back now that we've written it down correctly. 01202, yeah, that's fine. Now 0.3. Let's go back and get that one then. Press equals on that. 1.04077. 04077, 1 point. Let's just check that. Yeah, that's fine. Now we go to 0.4. Delete that. 1 point equals 09752, isn't it? This one will become a 2 because the 9 rounds it up. 09752, 1.09752. Let's just check that again. So yeah, that's fine. Good. So now let's work this out then. So what have we got? Here's a formula, h over 2. So I'm going to label it a capital I for the value of the integral according to the trapezium rule. H over 2, so it's 0.1 over 2. Open bracket, y0, which is 1, plus y, the last one, y4, 1.09752, plus 2 times, and the middle 3, isn't it? So I'm just writing these down. 4077 is the last of the 3. Close that bracket and then close the brace. Now we just need to tap it in the calculator. So let's get our calculator then. 0.1 over 2 divided by 2 times bracket 1 plus 1.091 plus 1.09752. plus 2 times. Now we open another bracket, 1.00150 plus 1.01202, and then plus 1.044077. Close that bracket, and then close the brace, so it's another bracket here. Now I'm going to toggle back and just quickly check that everything's been entered. It's a valuable and useful quick double check. It only takes a moment to do. 0.1/2, bracket 1 plus 1.09752, yeah, and then it's 2 times bracket 00150 was that decimal part, 01202, yeah, and 04077. Close the 2 brackets, press equals. 0.41035. 0.41031, isn't it? 0.41031 if we're doing it to 5, which equals, let's get that calculator back up. We could have written it as 0.5, but we're rounding to 3dp, so we're only concerned about 0.410 to 3dp. And that was to 3dp. So this stuff here is not really necessary, so we can get rid of that to avoid any confusion there. And there's our answer, 0.410.